Cap and trade is a regulatory system used to reduce greenhouse gas emissions and pollution. Cap and trade provides companies with a profit incentive to reduce their pollution levels faster than their competitors. The cap sets a limit on carbon emissions, which is lowered over time to reduce the amount of pollutants released into the atmosphere. Allowances are issued to companies, each allowing a specified unit of pollution. The trade creates a market for carbon allowances, encouraging companies to innovate ways to pollute less in order to sell excess allowances. The less they emit, the fewer allowances they use, leaving more allowances to be sold onto the market, incentivizing reduced emissions. The cap and trade system is cost-effective because it establishes the price of permits at an amount where the marginal costs are equal for all firms. Permits can be allocated to companies based on varying criteria. Common ways to allocate include equal distribution among firms, as well as distributing based on the firm's market share. Now, let's do an example to show how cap and trade works. In this scenario, we have two firms, Firm 1 and Firm 2, that each emit 15 units of pollution for a total of 30 units of pollution. The state government wants to reduce the amount of total pollution to 10 units, requiring the firms to abate or reduce their pollution by 20 units total. The government issues each firm 5 permits that allow each 1 unit of pollution. The total and marginal abatement cost equations are given for each firm, with A being the number of units abated. The marginal abatement cost is the amount it would cost either firm. To begin, let's calculate how much it would cost each firm to abate half of the 20 units required by the state. In order to do this, we need to plug 10 in for A1 and A2 in the total cost equations. After calculating this, we see that it would cost Firm 1 $80 to abate 10 units, and it would cost Firm 2 $60 to abate 10 units. This solution could work, but as we discussed, we know that the cost-efficient allocation of abatement is found where the marginal costs are equal across firms. We can find this number by setting the two marginal cost equations equal to each other. We also know that A1 and A2 together should equal 20 units, as the total abatement necessary by each firm will equal whatever abatement is required to get emission levels down to government standards. Using substitution, we find that the cost-efficient allocation of abatement is where Firm 1 abates 8 units and Firm 2 abates 12 units. With these cost-efficient numbers, let's recalculate the cost of abatement for each firm. Using these numbers, we find that at the cost-efficient solution, it will cost Firm 1 $53 to abate 8 units, and it will cost Firm 2 $82 to abate 12 units. Now, with all this information, we can figure out how many permits will be sold and at what price. Firm 1 and Firm 2 each begin with 15 units of pollution, and at the cost-efficient solution, they will abate 8 and 12 units respectively. This leaves Firm 1 still emitting 7 units and Firm 2 still emitting 3. Since each firm was issued 5 permits by the government, Firm 2 has a surplus of 2 permits that they don't need. On the other hand, Firm 1 is in need of 2 permits. The cap and trade system allows Firm 2 to sell its 2 excess permits to Firm 1. The price of each permit will be equal to the marginal cost of each firm at the cost-efficient allocation. Plugging our cost-efficient abatement numbers into each marginal cost equation, we find that each permit would cost $24, totaling in a $48 transaction between Firm 1 and Firm 2 for the exchange of 2 permits. Overall, the cap and trade system has been proven to work efficiently through existing policies in the U.S. Beginning in 1995, the acid rain program was established by the EPA to cut down on sulfur dioxide emissions. Since the implementation of the program, concentrations for sulfur dioxide have decreased by as much as 40% since 1990. The cost of compliance has been lower than estimated, now estimated to cost $1 to $2 billion per year, which is just 1/4 of the original EPA estimates.